Like someone was asking me this question this is from 2008 JEE Advanced. It's not very difficult, but those who have doubt, you can look here. A small block of mass m moves on a frictionless surface of an inclined plane. As shown in the figure, the angle of the incline suddenly changes from 60 to 30 at point B. The block is initially at rest at A. Assume that the collisions between the block and incline are totally inelastic. Now, the speed of the block at point B immediately after it strikes the second incline. So, what I can do is, from here to here, I do energy conservation and I'll get what is the velocity here. I can do energy conservation, I can get what is the velocity there. That will turn out to be root 60. Now, there is a problem that inclination is along this direction. Now, immediately it is changing the inclination, and they said like inelastic collision. So, it's always better to resolve the forces along the incline and perpendicular, resolve the velocity along the incline and perpendicular to the incline. So, this 60 thing, I will be resolving it along the incline and perpendicular to the incline. Now, if you notice carefully, this angle is 30, okay. So, but this angle is 60. So, this is going to be 30 and this is going to be 30. That you can manage, right? Okay. So, this is 60 degrees, this will be 30 degrees, yes, this will be 30 degrees, right? If this is 30 degrees, then this will be 30 degrees, then this will be 30 degrees. So, when you resolve it, root 60 cos the cos 30 and root 60 sin 30. Root 60 cos 30 will be this thing, root 60 sin 30 will be this thing, right? So, resolve it along the incline and perpendicular to the incline, and when E is 0, what will happen? Velocity of approach doesn't matter, velocity of separation will be 0. So, along this direction, velocity will become 0. So, its velocity will become 3 root 5. So, after collision, if it is inelastic, only 3 root 5 will survive. That is 3 root 5 is root 45. That's the first question answer, right? The speed of the block at B immediately after it strikes the second incline. Now, the speed of the block B at point C. Now, if it goes with the same speed downwards, what is the speed? Now, from here it is starting with 3 root 5. So, when it goes, see this 3 root 5 is here. I have just put in the figure so that I can see it, that's all. So, this 3 root 5 is here. When it goes from 3 root 5 from here to here, again I can do energy conservation. There was already initial kinetic energy half m into the 3 root 5 whole square, which is 45. Initial kinetic energy plus drop in potential energy mg into 3. Initial kinetic energy plus drop in potential energy is going as final kinetic energy. From there I will be getting what is the velocity at C, which is root 105. Now, in the next question, they are saying if the collision between block and incline is completely elastic, then the vertical component of the velocity at point B immediately after it strikes the second incline. So, again we will be going by the same thing. So, velocity here will be root 60, we understood, and we will be resolving it along the incline and perpendicular to the incline. But previously we said after collision, velocity in this direction is going to become 0, but it is elastic collision. So, what will happen? This root 15 will become root 15 in this direction. Velocity of approach is root 15, so velocity of separation will be root 15. Now, they are saying like what is the resultant of these in vertical direction. What you can do is you can resolve what are their vertical components and you can find what is the resultant. But I didn't do that because I can see like resultant of these two will be making 30 degrees with the horizontal. The meaning is 30 degrees with the incline, the meaning is it is going to be horizontal. But that's not easy to see every time. So, what we can do, we can resolve this vertical component and we can resolve this vertical component and we can see what is the resultant. It will turn out to be 0, right? Thank you.